Hello. Now we will calculate the force applied onto the single plate due to the other plate in case of capacitor. So we know this parallel plate capacitor consists of two parallel plates. One plate will be having positive charge and another plate will be having the negative charge. And obviously, if the sign of the charges are different, in that case there is attractive force acts between them. So basically this plate will apply a electrostatic attractive force onto the negative charge plate, and the negative plate will apply an electrostatic attractive force onto the positively charged plate. So if I'm calling this 1 and I'm calling this 2, this plate will be experiencing a force F21 towards the positive plate, and action reaction. The first plate will experience the force towards plate 2. Magnitude wise, if you see action reaction, magnitude wise these two forces will be same. F21, they will be same. We want to calculate this force. How much is the force which is being applied? Okay, so if I want to calculate the force applied onto plate 2, I have to calculate the electrostatic field nearby to plate 2 due to plate 1. So I'll calculate the electrostatic field nearby to the plate due to the plate 1, only plate 1. So this electric field will not have any component of electric field due to the 2, because you see, if we want to calculate the force onto 2, we will not take the electric field due to the plate 2. So the value of E1 magnitude wise will be equals to sigma upon 2 epsilon naught, because you see, for this point this plate will behave as if it's an infinite dimension plate, because you see, since it is a parallel plate capacitor, so dimension of D will be quite less compared to dimension of cross section area. So in that case, for all inside points, these plates will look like they are of infinite dimension. So I can use the formula for infinite plate. So this is the electric field which is being applied at plate 2. Now to calculate the force, we have a relationship between the force and the electric field. The force is equals to charge multiplied with electric field. So I'll be multiplying the charge onto plate 2 with the electric field due to 1. That will be the magnitude. Let's put the value. Charge onto plate 2 is Q. I'm taking the magnitude only. And E1 is sigma upon 2 epsilon naught. This value can be modified as Q square upon 2A epsilon naught. This is the force. Okay, so this is the force which is being applied onto the plate by the other plate. So each and every plate will be experiencing this force. Now this formula, we can rearrange this formula by multiplying and dividing this whole equation by A. So I'm multiply this equation with A, and I will divide that equation with A, so it will become A square, and Q upon A to the whole square will be sigma. So this whole formula can be written as sigma square A upon 2 epsilon naught. This is also a formula, but in terms of charge density. One more thing we want to calculate is the pressure. We know the pressure is equals to perpendicular component of force multiplied with divided by the area. This electrostatic force will be perpendicular to the cross section area. So if I divide this electrostatic force with the cross section area of the plate, I'll be having sigma square upon 2 epsilon naught, and this is the pressure due to the electrostatic force. Okay, so as you can see, we have calculated the force here. We have calculated the force, and we have calculated this different format of the force, and this is the pressure. This pressure is known as electrostatic pressure. Electrostatic pressure. So if you put a charged particle, or if you put any cross-section area inside this capacitor, that cross-section area will be experiencing this pressure, or we can say inside the parallel plate capacitor, at each and every point that much pressure will be experienced. So I'll suggest everyone should memorize these two formulas actually. Okay, so examiner directly asks question from using these formulas. So this is the force applied onto the electrostatic, applied onto the parallel plate, and this is the electrostatic pressure. Okay. Thank you.